Hello, everyone. Once again, welcome back to one more uh, powerful NASO PowerUp session this weekend. And so today we have Mr. Divin, a passionate astronomer, accomplished aeronautical engineer, and dedicated astronomy educator. With his fiery passion for rockets, will elevate your rocket science journey to new heights. I hope all of you are ready for this new insight into next generation of rockets. Over to you, Divin.
Thank you, Praveen sir, for the warm welcome. So, hi everyone. Good evening to one and all. So today we are going to have a power up session. And you know what's the topic for today, right? We are going to explore the next generation of rockets. Okay. So we are going to have a brief history of the rockets. We'll be going to see what's happening right now with the rockets. And we are going to see what is going to happen in the upcoming years. So all these stuff we are going to explore. So all these stuff we are going to learn. So let's have this journey. Let's have this journey to explore the universe. So I'll start the presentation right now. So we are going to explore the next generation rockets, right? So before going into the topic and all, I just want to ask you a small question. Okay, so it's simple. What is a rocket? So that's my question for you. Yeah, okay, fine. So basically, what we do with the rocket, or what's a rocket? It's actually a launch vehicle. Okay, so we use rocket as a launch vehicle to carry a particular payload to space. I know you people are aware of this fact. Okay, so we usually send the payloads to space to the Earth's orbit using the launch vehicle called the rocket. So that's a basic definition for the rocket. We don't want to go further into that. Now, we have the rockets. We have seen the rockets. How the rocket is going to work. How the rocket works. So basically, you all have heard of Isaac Newton, right? You might have learned about Isaac Newton in a physics class. So I hope you guys are familiar with the Newton's laws of motion, right? There we have one law of motion that's called the Newton's third law of motion. For every action, there is an equal and opposite reaction, right? We have heard this law several times in the school. So these complex structures, these bigger rockets, every rocket work on the same principle of Newton's third law of motion. So here we have one action force and one reaction force. So you know what's the action force, right? Without the action force, we won't get any kind of reactions. What we need here, we need to push the rocket upwards, right? We need to propel the rocket upwards. If we need that reaction, I should have an action in the opposite direction, right? So how can I get an action in the opposite direction? I should burn something over here that can create a force in the opposite direction, and that will be our action. So against it, the rocket will move. So how we are getting that action over there? That we are going to see right now. So if you're looking inside a rocket, there you can see something that's called the fuel of the rocket, right? So basically, if you see a rocket, we'll have a fuel, mostly it will be hydrogen, but I can't take fuel only to the space, because for anything, any substance to burn, I need oxygen. Okay, so I need to carry extra supply of oxygen along with me to the space, because when you're going to the space, you are not going to have oxygen over there. So what I have to do is, I have to carry oxygen along with me. So we'll have a tank of fuel, we'll have a tank of oxygen. This will get burned in the combustion chamber, and the flames will come out, which is the action, and the rocket moves upward. That's the reaction. That's a simple way how a rocket is going to work. Now, I just want to introduce you to something that is very common in every rocket. That's called stage separation. Why I am telling you about stage separation right now? is because when we are going to see the next generation of rockets in the coming minutes, you're going to hear this term stage separation, stages a lot. So at that time, I don't want you guys to be confused. So I'll introduce you to this concept of stage separation. So to introduce you or to teach you about stage separation, I'm going to take a rocket, which you guys are all familiar with. You are very familiar with this rocket. And that rocket is our ISRO's GSLV Mark III. Okay, so whenever you see a rocket, the rocket will be carrying a payload over here, right? If you're sending any satellite or any spacecraft, it will be sitting over here. Every other portion inside these boosters will be having the fuel, right? But do you think that if I'm sending the satellite or if I'm sending that spacecraft to the orbit, will the rocket completely goes along with the spacecraft to the orbit? Will the rocket as a whole goes to the orbit? No, right? Because we have the payload. That's the one thing that will go to the orbit, right? So what will happen to the other things? Because they are carrying fuel, they'll be carrying tons of fuels. And when we use this fuel over here, we don't want to carry this extra fuel to the space, extra material to the space. So what we'll do is, we'll simply separate the stages. Okay, it will eventually fall down to the earth and the other stages will continue its journey. Because you guys, when you're going to school for a day, say for example, you're going to school on Monday, we'll only take the books of the Monday subjects, right? We won't carry the books of the Tuesdays and Wednesdays because we don't want to carry the extra weight, right? Like that, our rocket is not ready to carry this extra weight because that will decrease its efficiency, right? So for that, to avoid that, we'll deploy these stages or deploy those parts. And this one, it happens with every rocket, most of the rockets, and that's called the stage separation. Okay, so stage separation is very much important. We're going to hear this term a lot when we are going to the next generation rockets. That's why I just introduce you to the stage separation part. Now we are going to see the stuff related to rockets. What is the life cycle of a rocket, which we are going to see today? Now we'll see what are the kind of rockets or what are the type of the rockets that existed many years back. Okay, like many years back, how did the rocket look? Now how the rocket is going, like how the rocket looks, what are the innovations that are happening right now? And in the future, that's our main goal. Okay, in the future, what are the innovations that are going to happen in the field of rocket? What are the changes that is going to happen in the rocket science field? What are the changes that are going to happen with the design, everything, every aspect of rocket? So we are going to see literally all these things, how the rocket looked years back, how it's looking right now, and how it is going to work in the upcoming years. Okay, so let me introduce you one by one. First, we'll time travel to the past. Okay, so we'll start with the origin of the rockets, how we made the first rockets, what kind of thought process might have happened during that time, everything we are going to look. Okay, so the first historical rocket, it's not a rocket, okay, so the first historical record of something that can propel out of itself. Okay, this one can self-propel. So this was actually a steam-powered pigeon. Okay, this is not a rocket, but this used some fundamental principles of rocket, like the action-reaction mechanism. Okay, so this was actually made during the 400 BCs. Okay, so like 2000 years back, this one was made. And this one actually works entirely on steam. This was steam-powered. So inside that, we'll have one bladder. So from here, we'll pass the steam. So as a result, this one was able to move this pigeon, this wooden pigeon, like for like 200 meters. So this happened during the 400 BCs. Then we came up with something really interesting. Okay, that one is called electrifying. Okay, this one also works on the steam only, but you can see this one is of not that much use. But the very fundamentals of rocket principles have been used over here. You can see that this one has actually a spherical ball like this. We supply steam to that from here. and we have two valves, and through this valve, the hot air will come out. So when the hot air comes from two opposite directions, it was able to rotate the spherical ball like this. So like I told in the beginning, this one was not having that much practical use, but we can see that the very fundamental principles of rockets have been used over here. Then going further, we had the firecrackers of China. Okay, so what these guys did was they actually take the bamboo. Okay, they'll take the bamboo stick. Inside that bamboo stick, they filled gunpowder inside that. Okay, so they used to do like that. They will attach the powder over here. They'll burn the stuff over here so that the arrow will move to very much higher. So they use these things, these fire arrows, for wars. Okay, for war purposes, they started using this, and this one is actually the historically this one we can call as the first rocket we are ever made. But this was not used to send humans or satellites to space. Rather, they used this one for war purpose. So that time the Chinese, the Mongolians, they were having the war, and from the Chinese, this technology got in the hands of Mongolians. From there, it eventually spread on to the other parts of Europe. So that's how the Europeans actually got the technology. This one happened during the 11th century. Okay, now we're going to see about India. Okay, so at that time, Indians, we were not very lagging behind in this rocket technology. We were also having very good rocket technology with us. And if you see the southern part of India, in like modern day Tamil Nadu, we have the Mysore, right? The Mysore kingdom. Then we had one ruler called Tipu Sultan. So this happened during the end of the 18th century, like the 1780s and all. These British, like East India Company and the Mysore kingdom, like they were having constant war. At that time, they also had the rockets made of irons. The Mysore army, they were having rockets made up of iron. So the East India Company, they were very surprised because this technology, they didn't have this technology, but we were having. Due to constant encountering with this technology also got into the hands of Britishers, and eventually they started developing their own technology. Now, if you come back again to the 20th century, this guy, okay, so he was called Robert Goddard, and he was the one who developed the first ever liquid fueled rocket. So we have the fuel. You might have seen the fuel in the beginning, right? There we used liquid fuel, but something really bad happened to this rocket. Okay, this was the first liquid powered rocket. This just had a flight for only 2.5 seconds. Okay, it went to a height of like 41 meters and it fell down. So that happened. That was the tragedy that happened to Goddard's rocket. Then, if you're coming back, if you're coming again, we have something. This happened in the Germany. That's called the German V2 rocket. This rocket is very special. Okay, why? Because this is the thing that literally changed everything. Because they were having that technology at that time. You know what? For what purpose they use this rocket? Because at that time the World War II were happening. This was in the hands of the Nazis, the people who ruled the Germany at that time. They were using this one for bombings to destroy the other cities and all. So for that purpose, they actually used this rocket. So this is actually a brief history of the rockets, how the modern day rocket evolved. You can see from here it evolved into this. This is actually like a 14-meter long rocket. Okay, fine. Now we are going to see the very beautiful space war or the space race. You might have heard of the space race between USSR and Russia, right? So Russia actually used the modified version of that German V2 rocket to send the first ever satellite to the space. That's called the Sputnik 1. Okay, so at that time, the Russia, US, they were having a cold war in between. They were not fighting with the weapons, but they were fighting with technologies, right? They were fighting to show who was having the most powerful technology over there. So they were having in a cold war. And during the 1960s, America, they actually sent human beings to the moon, right? For that, they used a rocket called Saturn V. So if you take the Saturn V is a massive, a giant rocket that was even bigger than the Statue of Liberty. So for a while, this one was the tallest and the most powerful rocket we have ever made. Until during the recent times, we know a company, right? SpaceX by the famous Elon Musk. So now we are going to see what is happening right now. So the Saturn V was the tallest and the most powerful rocket ever made by human beings. Okay. Then that title was eventually taken by SpaceX, one of SpaceX rocket that's called the Starship. Okay, so the Starship looked like this, was completely made of stainless steel. The Saturn V rocket, okay, that was having a height of like 363 meters. This one was having a height of like 400 feet, sorry, 363 feet. Okay, so this one is having a height of nearly 400 feet. That much tall the Starship is. So the Starship is currently the tallest and the most powerful rocket we have. And the SpaceX are actually doing the minute test on the Starship. You know why they developed the Starship? You know about Elon Musk. He has a very huge dream, right? So what's the main dream of Elon Musk? He wants to send humans to Mars, right? He wants to colonize Mars. So for colonizing the Mars, they have developed this Starship. This Starship is having a design that none of our rockets is having. It's having a very different design. Surface is covered with stainless steel. And if you see the Starship, this one is having a very huge supermassive booster over here. And this one is the Starship. Using this Starship, you'll be able to send cargo to the orbits, the orbits around the Earth. You'll be able to move to the moon. You can go to the moon. Moreover, you'll be able to go to Mars. And the company is saying that you'll be able to go beyond the Mars. So for that, they built the Starship. Okay. Now, coming to Starship, we are going to see what is happening with the rockets or what is going to happen in the future. That's our topic for today, right? So we are going to explore what are the different technologies that the different space agencies is developing around the world. A lot of innovations is actually happening. Okay, you know, Starship is actually innovation by the SpaceX. Now we are going to see some really interesting, really fascinating innovations that's happening around the world. So before that, I just want to tell you something. How many of you have played with a tiny rock and you used to attach strings to that, right? Then we used to rotate it like this. And if I'm throwing that, it will go to a very large distance, right? It can go to a very large distance. Imagine I am sending a rocket in the same way. I'm going to spin the rocket and I'm going to throw the rocket to the space. Will you believe me? Feels like I'm kidding, right? But it's not fun. There is a company that's based in the America, USA. So that company is actually called Spin Launch. Okay. So Spin Launch, as its name suggests, they are actually spinning the rockets, throwing the rockets to the outer space using a different technology which we have never seen. So this is going to be a technology. This is going to be very much interesting. This is going to be like kind of a modern day technology that is going to happen for the future. Okay, so if you're seeing the spin launch system, yeah, it will go like this. Okay, so if you're seeing a normal rocket, it will be in the launch pad. Okay, we'll fire the thrusters, we'll fire the engines, the fire will come out. Using that force, our rocket will move upwards, right? That's our conventional way of making the rockets or how our rockets works. But if you're seeing the spin launch rocket, I'll tell you how it's going to work. It will be thrown away to the space using something called an orbital accelerator. Okay, so this one look like this, and this one will be based on the ground. I'll tell you step by step. Okay, first they'll manufacture their rocket. They'll have their rocket. They'll assemble their rocket over here. This will be connected to a huge or a very big rotating arm. Okay, it will be having a rotating arm. At the end of the rotating arm, they'll attach their rocket. Okay, so inside this orbiter or inside this accelerator, there won't be anything. It will be complete vacuum. Okay, here it will be complete vacuum. They'll seal the place over here. That's why you saw something. The rocket is breaking through a surface and coming out, right? Because they don't want air to enter into it. What will happen if air enters into it? What can happen? Why they made it as a vacuum? Because air will offer resistance, right? To prevent that resistance, to avoid that resistance, they purposefully made the inside into a vacuum. And what they are going to do is, they place their rocket over here. They'll start supplying it with electricity. Okay, they'll use electricity to rotate the arm very fast. It will be having like 400, 430 RPM. It will have 430 revolutions per minute. You rotate like that. It will have 430 rotations per minute. It will go very fast. And at one particular time, what they will do is, from here to this portion, they will throw the rocket into the space. Let's see here, till now, they haven't started the engine, right? They haven't burned the engine. But using the kinetic energy from here, they are going to rotate the rocket very fast and they are going to throw that to space. Now you may ask, how it can go to space? By simply throwing, right? How it can go to that much distance by simply throwing? There comes the use of something called kinetic energy. Okay, you have heard of, I think you might have heard of kinetic energy. So due to the high velocity of this rotation, you'll be having a kinetic energy. Due to that kinetic energy, it will be able to go to a very high distance. At that time, we won't fire the engines, engines won't be fired. The rocket will go to a very huge distance, like 60 kilometers, it can go up to. From there, you know what will happen? The stage will separate. Okay, the first stage will separate. It will return back to Earth using parachutes. So it's a reusable. The first stage is reusable. They can reuse that stage for the another launch. And the other portion, the satellite or the payload, the second stage will start firing its engine from that altitude, and it will place that object in the low Earth orbit, the orbit that is very near to the surface of the Earth. So how this basically works is as simple as this, okay? So this is one of the most complex engineerings, right? Because can you imagine if something, a small fault happens over here, imagine the rocket spins like this, it came here, rather than throwing from here, if you are throwing from here, what can happen to the whole apparatus, right? It completely get damaged, right? So we have to be that much precise. We have to do that much good engineering. Then only we will be able to give the rocket that exact push without damaging anything. So the engineering side has to be very strong for this. And there are a lot of people criticizing this also. So we are waiting for this technology. Hope it works well in the future. So we're using this. Can you imagine how much cost we can reduce, right? Because if you're having a normal rocket, the conventional rockets that is launching from the launch pad, we have to burn a lot of fuel, right? Because we have to take that to the space. But if you're seeing here, compared to a normal rocket, it can use small amount of fuel, right? It don't need that much amount of fuel because we are using the velocity from here to go to a height. From there only we are using the fuel to burn the engine. So these kind of rockets will be very lightweight. So we don't need to carry that much amount of fuel inside that, so that the cost, we can reduce the cost of space flight. We can reduce the cost of the rocket. Because in the future, that is going to play a very important role. Who can build the rocket at very cheap rate, or who can provide the service at very cheap rate? That is going to play a very significant role. So all the companies, all the space agencies, they are working towards cutting the cost to make it much more efficient. So here comes the spin launch. Okay, so that's also about spin launch. They have done their test and they're working on it. They're actually planning to do furthermore. They are actually trying to find a very good location for this one. So the work is going over there. Hope we'll get the service in the future years. Okay, so everyone is actually waiting for this one, how it's going to end. Now, we're done with the spin launch. We have going to something really interesting. Okay, so when it comes to the next one, it is not a normal rocket. We are going to discuss about the 3D printed rockets. Okay, so we are not going to make the rocket using the normal technologies or using the hardware and all. We are going to 3D print the rocket. And imagine what kind of technology that is. So there is a company that's also based in the US called Relativity Space. Okay, their main aim, their main intention is to make rockets that are 3D printed. They are going to build 3D printers. So you know what size of a rocket, right? It is so big. To print a rocket that much bigger, I need a very huge or a very big 3D printer, right? So for that, the company itself made a very big or the biggest 3D printer, and they started printing rockets. So how can they print the rockets, right? So what basically 3D printing is, imagine I have this box with me. If I have to 3D print this one, I'll make a design of this one. I'll send it to the computer using the software. What I'll do is, we'll have the robotic arms that will supply the material to here, and we'll start printing it by layer. So it will go like this, and eventually it will result in the bigger piece. So talking about relativity space, we should talk about one rocket that has created history, and that rocket is called the Terran 1. Why Terran 1 is very important? Because Terran 1 is the world's first 3D printed rocket that has taken a launch. Okay, so we had the Terran 1. This was made by the Relativity Space. 85% of the components of the rocket, nearly 85% of the components of the rocket is actually 3D printed. Okay, so this is not a normal rocket. This is not a conventional rocket. The picture you are seeing over here is actually of a 3D printed rocket. Okay, so before this, before the Terran 1, this happened like 2-3 months back only. Before Terran 1 itself, many space agencies have tried this 3D printing technology. Okay, they tried the 3D printing technology, and out of that is the very famous SpaceX. So during 2014, we have the Falcon 9, right? The reusable rocket of SpaceX. So they used one of their main oxidizer valve. We have the main oxidizer valve in the engine. They 3D printed that component, not entirely the rocket, only that oxidizer valve they 3D printed during 2014. And during 2017, we had a 3D printed rocket, and we have actually successfully, 3D printed engine, okay, not the entire rocket. We 3D printed one engine of the rocket, and we used that in a rocket during the 2017. So 3D printing is not a relative new technology, but what these guys did, what the Relativity Space did was, rather than printing a simple part, rather than printing a tiny part of the rocket, they started printing the rocket as a whole. Okay, so they completely 3D printed the rocket, and that's called the Terran 1. So if you see the 3D printed rocket, how it won, like how we can 3D print, I'll show you one video. So the 3D print will actually happens like this. Okay, we'll print the layer by layer, we'll print the entire stuff. So there are a lot of advantages for this 3D printing. You know what the advantages of the 3D printing we have? If you're making a normal component of a rocket, if you're making the body of the rocket in a normal way, we have to make it into many pieces. Then we have to assemble the different pieces. Then only we'll be able to get that entire body. So it will be made of a lot of pieces. We have to assemble these pieces together. Okay, but when it comes to 3D printing, you'll be able to print that whole body, the whole body in a single part. You don't need to have many parts. You don't need to have to assemble it. You can print that as a whole. So what we can reduce over there, we can reduce something there, right? Time. If you are using, like, say, for example, you are going to take 9 months to manufacture the injector. There's a component called injector in the combustion chamber of a rocket. You basically need 9 months to manufacture that using the conventional methods, using the traditional methods. There also will be having many pieces. You have to put these pieces together, then make the injector. But when it comes to 3D printing, you can print that in just weeks, or no 2 weeks. That time you can save, right? So, instead of spending 3-4 months, like 3, 4, 5, 6 months, you can do the same thing in weeks. So that's the advantage this 3D printing is providing, and relativity space is actually working on that. But this mission, right, Terran 1, it is only a partial success. It was not a complete success. The first stage, it was successful, it was fine. But the second stage actually failed to go to the orbit. But fine, that's fine. Because being it a 3D printed rocket, we're actually working on that. Hopefully, we'll be able to clear everything, correct everything, and we can use the most out of this technology. Okay, so we are awaiting for that, the 3D printed rockets. So it will come in the future, and relativity space is actually leading that race. Then, talking about the 3D printer, if you see the 3D printing, the surface of the 3D printing will be like mostly having some fine lines like this, because we have this circular pattern we'll be making using the circular pattern. Okay, so people started asking, okay, if you are making it in such a way, then the surface will be very rough, right? So it can, the aerodynamic forces, aerodynamic drag, everything increase. So when they asked this question to the CEO of the company, I was like, no. Why? Because they will do a lot of simulations. Before printing, they will do a lot of computer simulations, and then only they will start printing. So all these steps, all these calculations will be previously done. They'll done it prior, then only they'll start printing. So that's about the 3D printed rockets. Now, we are going further. So we saw 2 innovations. One is the spin launch. Then we saw the 3D printed rockets. What's next? What kind of innovation is next? So let me show you something. Then we have something that's called the methane powered rocket. So what actually is the methane powered rocket, right? So I told you, when we're having a rocket, we'll have a fuel, we'll have an oxidizer, both will work together, both will combine together to get the combustion done, to create the thrust, right? To create that fire and the stuff coming out from the exhaust. So instead of hydrogen, one company situated based in China, the company is called Landscape. Okay, what Landscape did was they built and launched the world's first methane fuel rocket. So instead of using hydrogen or instead of using kerosene, they started using methane as a fuel. So you may ask, what is so special about methane? Why we are talking about methane? It's just a simple fuel. So what specialty do these guys have done? So if you talk about Chinese, this rocket, it's called Xiu-2. It's a Chinese word. Okay, so when it comes to this rocket, even before this rocket, like got this title of the world's first methane-powered rocket, there are many giants in the space field, like the SpaceX, the relativity space which we talked just before. Everyone was actually working on the methane-powered rocket, because the Starship, right? The biggest, the most powerful rocket currently we have, right? The Starship, Elon Musk actually planned to fuel that with methane. He actually planned to power that with methane. So Starship is actually a methane-powered rocket. The relativity space, they're actually building rockets on the methane-powered. The Chinese space agent, so this guy is the private company, the Chinese private company called Landscape. They were also working on the methane fuel rocket. But before the Starship and the relativity space, they were successfully able to launch the world's first methane-powered rocket. Okay, so when it comes to methane, there should be some advantages of methane that we are like very much benefited of, right? Then only we'll go for methane because we already have hydrogen. We are already working on kerosene. Then why we should go for methane? There should be some benefits it's having, right? Some characteristics methane is having that is not present in hydrogen or kerosene, right? So due to that features, due to that benefits only, we are going for the methane. So what are the advantages methane is actually having, or the methane powered rockets is actually having? Let me show you the advantages. So when you see the methane will actually look like this. We'll go for some small chemistry. Okay, so it'll be having a carbon on 4 sides, it'll be having 4 hydrogen atoms. Okay, hydrogen will be here, hydrogen will be here, here also hydrogen, here also will be having hydrogen. So this is one of the most simplest hydrocarbon we are having. If you're burning methane, okay, if you're burning methane on one side and if you're burning kerosene on the other side, methane will have like most of it burns completely. But when it comes to kerosene, something called incomplete combustion happens. So when there is incomplete combustion happening, the chances of air pollution is very high. Okay, so right now we know what are the global hazards happening, what kind of air pollution, like we are very much affected by the air pollution. So we need to reduce the risk of air pollution and all. So for that, currently we are trying to switch to a very safe, very clean fuel, and there comes the use of methane. So if you're burning methane, what you will get is you'll mostly get water, then you get little amounts of very trace amounts of carbon dioxide and nitrogen dioxide. So if you're burning kerosene on the other side, the amounts of carbon dioxide and nitrogen dioxide and sulfur, all these things are very high. So if you're taking the environmental aspect, methane powered rocket is very much efficient. Then there is one more thing. If you're seeing methane, now we talked about methane and kerosene, right? Those are the fuels we are using right now. If you're taking hydrogen, because hydrogen is the most commonly used rocket fuel. We're using hydrogen on one side, we're having methane on the other side. What advantages methane is having over hydrogen? You know, one thing, hydrogen is actually very much efficient than methane. But still, why we are sticking on to methane? That's the question. So you can guess your answers why we are still sticking on to methane. Okay. So when it comes to methane, if you're comparing that with hydrogen, hydrogen is having a low density, very low density. So hydrogen needs a lot of space to occupy. On the other side, methane, it is having a very low density so that it can occupy in a very small volume. So now think about the fuel and the tanks and the fuel tank structures. You're having hydrogen on one side, it needs a lot of space. On the other side, you are having methane that requires only a small volume. So what advantages I'm getting from the both? Or what advantages I'm having from the methane? Think about it. What advantage I'm getting from methane? One side I have hydrogen that needs a lot of space, a lot of volume for occupying. The other side we have the methane that's having a very high density, so that it is able to occupy in a very small volume. So what advantage I'm getting? I don't need to carry that much bigger fuel tanks, right? I can carry fuel in a small volume. So I can use the other portions to carry the space payloads. I can significantly reduce the weight of the rocket. Okay, I can also reduce the cost of the rocket. So there comes the importance of methane. Okay, so if you're comparing methane to hydrogen, it has many advantages. If you're comparing that to kerosene, it's having more advantages. That's why these giants, the SpaceX, the Relativity Space, the Landscape, the private space agency, private space company in China, everyone is running behind methane. Okay, so everyone is running behind methane due to all these reasons. Then there is one more thing. If you're seeing methane, methane can be produced on the other celestial bodies. Okay, So methane is actually CH4. We'll be mostly using liquefied version of the methane. Liquid CH4 will be used along with liquid oxidizer as the fuel and the oxidizer. So what I'll do is, from the other planets, say for example, we are going to Mars. Okay, Mars, we have Mars atmosphere is containing a lot of moles of carbon dioxide. Okay, and on the polar regions, we have the ice caps, right? The beautiful ice caps. So it's having oxygen. Sorry, it's having a carbon dioxide. It's also having water. So using a reaction, we'll be able to make methane from both of them. So I'll be able to make the fuel or make the fuel for the rocket from the other planets or the other planets itself. I don't need to carry the fuel from here. I can make the fuel from there. So those are the advantages provided by the methane. If you're using methane as a fuel, you're going to get these advantages. So if you're taking the methane, mostly it's having a high performance than the other fuels. It's actually very simple and very cheap to produce. It's having an environmentally friendly behavior. Okay, if you're burning something that has the property of incomplete combustion, if that's not burning completely, it can get deposited on the nozzle and on the exhaust of the rocket. That's not at all good for the rocket. Okay, so if you're burning kerosene, this can happen. The incomplete burning can happen, and the incomplete burning of hydrocarbons is not that good. So there comes the use of methane, where we get a most like the combustion happens completely, and we'll be able to reduce the amounts of deposits. So that's about the methane fueled rocket. That's about the landscape, the private space agency in China. So they built and launched the first methane fueled rocket to the orbit. And in the future years, you will see a lot of space agency running behind methane, using methane as the fuel. So all these things are going to happen in the future. Okay, so wait for it. Now, we are going to see one more space company. If you're talking about the reusable rockets, if you're talking about the innovations in the space field, you can't never miss this company, right? Company owned by the billionaire Elon Musk, right? The SpaceX. So SpaceX is having rockets. That is the first orbital class rocket capable of reflight. They're having the reusable rockets. So this is the most trending technology we are having right now, because they're able to reuse the first stages recovered from the rocket. Okay, so how they are able to do that? Just go and search for the SpaceX website. There'll be a lot of videos about the reusable rockets. If you go there, you can see a lot of videos about the failures of the reusable rockets. Why I talked about the failure is because this was actually a plan of the SpaceX to build a reusable rocket to get the first stage back to Earth. They tried for it at the beginning, just a complete failure. No, it will land on the legs. So by the way, if you see the SpaceX reusable rockets, it will be having 4 legs made of carbon fiber. Why we use these legs? Simple question, right? So we need to safely land this on the ground. So these legs, the carbon fiber legs, they'll be closely attached to the body of the rocket, attached to the fuselage of the rocket. And once it approaches the target landing site, once it comes very close to the landing site, the legs will get deployed and the rocket can safely land over there. So that's the use of the landing legs over here. And now I'll tell you how the rocket is going to work. Because SpaceX is having the Falcon 9, the Falcon Heavy. Both the Falcon Heavy is having 2 boosters on the sides. Okay, so they're able to recover both the boosters. They're able to recover the booster of the first stage of the Falcon 9 also. So in that way, they're actually cutting the cost, right? They don't need to make new rockets every time. They can simply reuse the first stage. So this was one of the most brilliant innovations that ever happened in the space field. That has literally changed everything. Okay, so SpaceX is having that technology. Now, a lot more companies like the Blue Origin, everyone is also trying to do this. They itself have this technology. Okay, now, how this is going to work? That's the question. So imagine I'm having one Falcon 9 with me. Okay, having one Falcon 9. Falcon 9 is the one of the rockets made by SpaceX. So as it take off from here, the staging occurs or the stage separation happens. I told you about stage separation at the beginning, right? So the stages will separate. We'll have the first stage. This is the first stage. This will be the second stage. So the second stage will be carrying the payloads. Okay, it will be conveying the payloads. It will go into the orbit. You can see it is traveling to the orbit. On the other side, we'll be having the first stage that has done its job, that has taken the spacecraft or the second stage to a larger heights. Now, what happens to the first stage? So what SpaceX did was they tried to return back this to the Earth. So how can they return this? How they were able to return this? They actually use something called the landing legs. Then they had something over here. You can see some white fumes coming from here, right, on the top surface, but here it's not present. What they'll do is, once the first stage separation happens, they will use the cold gas thrusters over here. Okay, so these thrusters fire the gas in every direction so that the rocket gets flipped. The rocket gets flipped down. It will turn like this, and from here, we'll again start firing the engine. This time we are not firing the engine to make it go upwards. We'll fire it in a controlled manner. We won't fire that in that much power. Okay, we'll fire it in a controlled manner to safely land that on the surface. Because if I'm not firing the engine, it will freely fall down at a very high speed, can get crashed down. So I have to reduce the speed. To reduce the speed, what I'll do is I'll use the thrusters to reduce the speed, and eventually the first stage will touch down on the ground. So this was one of the very groundbreaking technology developed by SpaceX. This was very much fascinating. This was very much interesting. This actually forced every other space agency to go behind the reusable rocket. Okay, if you go into the previous slides, we talked about all these things, right? Suke, we talked about the Terran 1, everything. Every rocket agency is trying to make their rockets reusable. For what? To reduce the cost. Okay, to reduce the cost, every space agency is actually trying to make their rockets reusable. Here also you can see that if in the case of spin launch, they are also recovering the first stage, right? Using the parachute. So everyone is going behind the reusable rockets. If you're seeing the Starship, the most powerful rocket which we are having right now, Starship is also a completely reusable rocket. Okay, so having two stages, we can recover the first stage, and the second stage is able to return back to Earth. So this one is also a completely reusable rocket. So reusability is going to be a trend in the future years, and everyone will be going behind reusability. When it comes to reusability, I couldn't miss one mission. Okay, that mission is very close to every one of us, our hearts. Why? Because our space agency, our ISRO, our space agency is also working on their reusable rocket. Before that, I'll show you how the Falcon Heavy's boosters are landing. Okay, so I told you about the reusability, right? So what will happen is, after the first stage can land on the landing site like this. You can see the legs coming out, right? It will come out only when it gets closer to the surface. That's about the SpaceX reusable rockets. So yeah, I was talking about ISRO, right? So if you're talking about reusability, ISRO is also building their own reusable rockets. And that's the RLV mission. Okay, reusable launch vehicle technology development mission, demonstration mission. So what's happening over here is, India is building its own reusable rocket. Okay, because we need reusability, we need to reduce the cost. If we are able to successfully make this mission, if we are able to complete the mission, we'll be able to reduce the cost. Listen carefully, we'll be able to reduce the cost of space exploration. We'll be able to reduce the cost by nearly 80%. Okay, if some space agency is actually charging like, say for example, $20,000 per kilogram for a near Earth orbit, will be able to charge like around $4,000 only. So in that way, we'll be able to reduce the cost of space flight, and we're actually working on that. Per kilogram, we'll be able to reduce the cost. So this one is the India's RLVTD missions. A lot of studies is happening over there. We're actually planning to send humans to space, right? So for all these purposes, we are going to use this. It's still in progress. We are working on it. And this is one of the most challenging, one of the most like, we need a lot of technology, a lot of engineering, very precise engineering for this one. And all the scientists on our ISRO, in our ISRO, is actually working very hard to make this mission successful. And that's the RLV-TD mission called the Reusable Launch Vehicle Technology Demonstration Mission. Okay, so if you're seeing the RLV-TD mission, it actually combines two things. Okay, it will combine the complexity of a launch vehicle, rocket, launch vehicle or the rocket, along with the aircraft. Okay, like kind of the space shuttle. Okay, so if you're seeing the RLV-TD mission, if you're seeing the pictures of that, you can see that it's having an aircraft. It combines the principles of aircraft along with the launch vehicle. So all these, if you want to go see further, you can use the ISRO's website. Okay, there you can see the gallery or the experiments we are doing with this one. All these steps are present over there. Okay, so this is our first step. This is ISRO's first step towards the fully reusable launch vehicle. So for what? To reduce the cost of space access. So we are trying to reduce the cost as minimum as we can. And here, our first step is the RLV-TD mission. So that's about ISRO. So we are also working on that. We are not lagging behind. We are also working on this cutting edge technology. Now, okay, so we talked about many rockets. All these things are very much essential for us. We can't stick on to the current technology for like nearly 50, 60 years in the upcoming years. We can't use the same technology for the upcoming years because we won't grow. We will still get stuck in the same place. That's why all these companies, all these agencies, they are trying their best to bring out innovations, to bring out, use their creativity, to use engineering, to help the mankind to explore the space. Why? Because we can't use our current technology for every time. Okay, we need to upgrade. So everyone is working towards it. So all these stuff, the upcoming years, we'll be able to see all the upcoming missions, all the things we were talking about, the spin launch related to space. Everyone will be working very hard, even our ISRO. And hopefully in like 5 to 6 years, you'll be able to see all these technologies doing successfully. We can wish them all the best. So let's wind up. Thank you guys. So if you're having any doubts, you can ask in the chat box. Prince, hello.
So we express our profound gratitude to Mr. Devindraj for imparting the enlightening insights into the future of rocket technology, which covered a spectrum of fascinating topics, whether it is the innovative concept of spin launch rockets or the most ambitious reusable rockets. So we would like to inform our audience that a YouTube chat is live now. If you have any questions, please feel free to type in the chat. Please write the questions in the chat. So the first question is it possible for launching the rockets for human missions through the spin-through technology?
Actually, currently we are actually working on the small satellites only, the spin launch. Okay, like nearly 200 kilograms or 1 because you can imagine how difficult it will be to send the humans through this, because you will be continuously spinned and do. So, but they're actually planning to upgrade their missions. They're planning to send this mission directly to the moon and do. So they're currently working. They're in the budding stage. This company is actually in the budding stage only. Because its orbital accelerator itself was came live in the 2021 only. So just 2 years. So first they are working on the smaller ones. Now they go to the bigger ones, like sending directly to the moon. Okay, so there also we need to check for it. We need to have a lot of studies. Why? Because can you imagine, like if you're spinning continuously over here, it will be very difficult for you, right? So they have to do a lot of experiments. Then only you will be able to give a correct answer for that.
Yes, sir. And is there any current rocket eco-friendly as it has large amount of carbon combustion, or is there any way to
Exactly.
do it?
So when it comes to eco-friendly rockets, there comes the use of the methane-powered rockets that are the most eco-friendly right now. Okay, so if you're comparing this with the other fueled rockets like the hydrogen fueled rockets and all, the methane fueled rockets like the SUP2, they'll be the most eco-friendly.
Okay, sir. And during the process of 3D printing of rockets, what materials are used?
They'll mostly use aluminum, the alloys, and they will actually use some kind of materials that is actually used by NASA, kind of alloys to prepare the 3D printing material. Okay.
So, yeah, thank you, sir, for your valuable insights. Now I would request
Thank you, Prince.
Praveen, sir, for closing remarks.
Thank you very much, Devin, for your insights into next generation rockets. And thank you, Prince,
Thank you,
for asking wonderful questions from our audience. Okay, so before we wrap up, I would like to say that, to the audience, all of your questions are very good. Actually, there are a lot of questions popping up from our students, but we don't have enough time to answer all of them. But don't worry, okay, we have, all of you have chance to ask in the community. Okay, so let me share my screen. You can see in the community, actually, when you log into the community, you can ask the questions below the PowerUp post. Okay, so when you open the community, you can see the PowerUp session here, and below that you can see the comment section. In the comment section, you can ask as many questions you would like to ask, and Divin sir, Prince sir, and others, all of our educators are ready to answer your beautiful questions. Okay, so do not worry, please come on board the community and you can ask a lot of questions. Thank you very much. Thank you, Devin sir. Thank you, Prince.
sir.
Bye bye.
Thank
Take
you,
care.
Prince.
Happy
Thank you,
weekend
Prince.
to everyone.